Hello everyone, in this video we demonstrate the next generation network management with OSS-GPT. So OSS stands for Operations Support System, which is a tool to network management alongside the BSS Business Support System. In this demo, we are interested in the OSS. So this latter will handle infrastructure management, network resource management, and service management. OSS components are typically software-based systems that expose some APIs to manage each type of these resources. So we will be having APIs to manage infrastructure, to manage the network resources and services. To simplify the interaction with OSS, standardization bodies such as ETSI, TM4UM, and 3GPP are adopting the intent-based networking concept, which introduce an abstraction layer allowing users to define what they want, the desired outcome, rather than how to achieve it. This is called the intent or the intention of the users. And these intents are usually expressed in YAML or JSON formats that will be used, for example, in the body of the OSS northbound APIs. However, still, these formats are difficult and time-consuming to create, especially for users with little domain knowledge. Also, user interaction with the OSS can lead to multiple API calls, each requiring a distinct JSON payload, which will add complexity for users to adopt this IBM concept. For example, this is the Eurocom's OSS APIs, and each endpoint will require a JSON payload. Therefore, moving towards using natural language to express intent is a natural transition to next generation IBM. For example, an intent could be deploy a communication service for a 5G network supporting XR. And then the IBM-enabled OSS can automatically translate this into multiple API calls with the appropriate JSON payload for each API call and then execute these API calls to fulfill the intent. Therefore, we need an AI approach that can understand human language. In the state of the art, large language models are the best candidates for this type of tasks. However, this task is a very complex one that one agent LLM cannot handle. Therefore, in OSS-GPT, we are using multiple LLM agents, each responsible for a specific role. OSS-GPT is composed of 4 main agents: the assistant that will interact with the users using natural language, planner will plan the set of API calls to fulfill the intent, executor will execute each API call based on some tools, and the reporter will report back the results to the users using natural language. So this is the Eurocom's OSS frontend, and in this demo, we are interested in managing infrastructure and services. So for the virtualized infrastructure, here we have 3 VIMs for different regions. And for the services, these can be composed of radio access network instances, core instances, and application instances. This follows the 5G and 6G infrastructure, where we have radio access network that can be composed of G-Node Bs, UEs, etc. We have the core network, and we have some vertical applications on the edge or cloud. For example, the first service is composed of one core network instance, which is deployed on the second VIM, and one RAN instance, which is deployed on the third VIM. To create these services or subservices, we have to choose the type of the subservice, either RAN, CN, or MEC. Also, we need to choose the VIM where to deploy this subservice. After that, we need to upload the YAML file, which is the all intent structure. For example, the YAML file for the core network blueprints is this one. As you can see, it is very complex to create for users with limited domain knowledge. Now, let's showcase some of the OSS-GPT use cases. For example, the user can ask general questions like, how are you? And for this one, OSS-GPT will not request the planner, but it will respond directly from the assistant to the user. This is the response of OSS-GPT. This is a second example where the user can ask what OSS-GPT can do, and this is the response of OSS-GPT. The user also can ask questions about the infrastructure, like how many VIMs are in the system. This requires some API calls, so the assistant here will request the planner and the executor to plan and execute the set of API calls. This is the response of OSS-GPT, and if we check the logs of our OSS, we can see that the get vim endpoint was called. The response was 3, which aligns with what we have currently. Now, let's see this second example. Please delete the last one. And OSS-GPT here will know that we'll delete the last vim because it has the memory. It's like a chatbot system. This is the response of OSS-GPT confirming the deletion of vim 3. And you can see that it used the delete endpoint to do this. And here in the logs, we can check that. And also in the front end, we can see that only 2 vims are remaining. Now, let's showcase a complex intent that will require a lot of API calls. For example, the user wants to create a service, and inside the service, we will have one subservice that is radio access network subservice, and this subservice will contain one xApp, KPM xApp, which will retrieve some KPM monitoring from the Gnode B. So this is the intent of the user. Create a new service with the name demo service containing one RAN subservice. This latter contains one xApp using this image, and this should be deployed on the second vim. During the execution, we can see the different exchanges between the planner and the executor agents, where the planner is planning the API calls and the executor is executing them based on the tools. This is the response of OSS-GPT, confirming that the demo service has been created successfully. We can see here the different endpoints that have been used by the planner and the executor to get the vims, get the package, which is the KPM xApp, create the package for the KPM xApp, and this is done by a homemade specialized LLM that is trained to create this type of JSON. So we use this LLM as a tool for the executor to generate this blueprint, and then this blueprint will be used as a body to the create package request. And then at the end, when the package was created, it called the create subservice in the Vim 2. If we check the logs of the OSS, we can see the different endpoints that have been used by OSS-GPT. In the front end, you can see that demo service is created, and it contains a one run subservice deployed on the Vim 2, which contains the KPM xApp, and it is instantiated and running. So in this demo, we showcased how the users can introduce some natural language intents to OSS-GPT and how OSS-GPT translate them into API calls and execute them and then respond back to the users using natural language.